So hi everybody and welcome back to our C++ tutorial series for absolute beginners. This is video 228, and in this video we continue with our exercise. I started in my last video with states and want to try to explain states, but don't worry, we dive not too much deep into states because I want just make an introduction for the future that states can help you a lot in coding. So in my last video, you can see that was this picture here where I tried to explain you that I have, for example, an input of 4 nodes. Then I have a certain coding for that. We programmed that it can handle 4 inputs. But the problem was this coding, what I made for 4 inputs, could not handle this input for one. For example, for 1 node or for no nodes. And for these situations, we need special code. And this special code we call then state. So you can see for 4 nodes, I have a code. This is state 1, can handle 4 inputs. Then I have here, for example, 2 inputs that needs again a special code. Then I have the state 3. And that was the last time what I told you. And here then I showed you on Wikipedia there is also a state machine. This was the finite state machine. That's not very important. I said you don't have to watch here all the difficult parts here, the theoretical parts. This is in future when you get better, but right now what you really need to know is this little diagram and this little example I want talk in this video today. You can see here is a turnstile picture. This is our real world object, and here they created already a state diagram. And interesting is about the state diagram, you can see there are only, let's say, 3 main things which you have to remember. One, this is here the start point. This is this black arrow which says here I start. Then the second one is this circle, and circle represents here states, right? And how you name these circles, it depends on you. You can see here they are called locked and unlocked, and when I go here down, for example, here they are called start 1, and then and found, I found, C found, error state, and success state. And here they call it S1, S2. These are placeholders again. This S1 you should declare perhaps here on top and say what S1 is and S2. Because this one is most time used, but careful, when you use placeholder like this one, S1, S2, which I used in my version as well, this one is placeholder. Placeholder means you should explain it here anywhere what S1 means, because nobody understands this, right? And then so on. So this is the second thing which you have to know. So the first thing was the start, the circle is the state, and then we have arrows. And arrows here are very important because these arrows are named arrows. You can see in our flow chart they were not named, they were just indicating the flow. Here these arrows have a name, and these names are inputs. And that's very important in state diagram because these inputs are characterizing if we can change a state or not. You can see we have here the state, for example, locked. This input arrow says if I use a coin, I change my state to unlocked. You can see the state reacts to inputs in a state diagram, and that's the whole point what you have to understand. But important, careful, input must not change the state. For example, here when I'm here and use the coin, I change the state, but here I use the coin again, I'm not changing the state. So they are trying to simulate this whole system in a very simple way. And now I want to show you the same thing here. Wait again, oops. So this thing here in a coding, I said in my last video, if you want, you could try to code this one, because this is a very nice starter example, to code example, this real world for training, but you don't have to, because that would, it's too much, but not really too much. When you use the state diagram, you will see it's not too much. But let me show you how I started as a starter to code this. So here is my try as a starter. And what I did here, I will not go through it. I will just indicate it what I did. I said, okay, yeah, I have to try to simulate this one. Then I have to declare variables. Okay, I declare here variables like coin, unlock, push, rotate, because these variables are describing the things which I need. Variables are all time describing things which I want use on. So you can see I want put in a coin, I want push this metal, I want, and this metal will rotate, and so on. And then you can see, okay, now I have to use these variables probably, and I started here just for fun here on bottom, because when we start with main, this is start the simulation. And then I created here an object because I said, yeah, I use a class. Why not? Class, we are learning classes. And then I said, okay, here, I go to the point where I try to push this. And then when I try to push this, that was this simulation. I said then push through, that is the person who is trying to push this one, and then I have to react, and react I make with a function, and this push here, this push try is my input that was here, but I said, okay, when I push this one, perhaps I need check there also if there is a coin, if they throw in a coin, so that then I made here a coin param, and then I created here this function, and then you can see I make here if check with coin and param, and actually this one is not wrong, but this is also not good. And why is this not good? I want to show you. Now, when we use the state diagram instead, the state diagram here says, for example, I said I need, in my code here, let me show you this. I used a push and a coin as an input, right? But the state diagram says here, oops, let's go back. The state diagram says here, actually, you don't need both. You can check them separately. For example, you can check coin, then I will change, or you can check push, then I will stay. And yeah, in my approach, I tried this, and then I have also here a variable rotate, which is not really needed. But of course, if I try to use this variable too, I can. And the important message is, first of all, this is not wrong, but this is too much work. And this is normal when we start prototyping as a beginner. But if you get better and better in programming, you want to try to avoid too much work in future, because too much work is time, and you don't want to waste time. You want more free time than coding time, and then the state diagram comes in handy. What you do is normally, instead starting here directly with a approach, with a random approach like me here, you would make the state diagram here first. So this theoretical part here, this is the state diagram. So they started with this picture, then they created the state diagram, and now they see in state diagrams, like I said before, important is the state and the inputs. And now we can create a code for this one in a very easy way, just to consider the state and the input. And let me show you what I could make here. So, and we compare here, this was the random approach, which is not wrong. So don't understand me wrong. This one will also work. It's equivalent, but has more functions, has more redundant things. But in the end, this one would work too. But look what I can do with the state diagram. The same thing here. Now with state diagram, look this. I create again the input and states. I have here a state. I have here a second state. And my state I called locked, and it is just one variable, because if it's locked, I set it true, which means the state is locked, and false would be the state unlocked. So one variable here, and then you can see I have only two inputs here. This is the coin input, can change. Coin input in this state stays at the same time, and then I have this push input. And this one we have to program as well. The start condition is our the start condition, very important. This one I'm programming here too. The start condition here is the initial value in my coding. Initial value means here I create the variables, but here I assign them values, and these values are my initial values. So you can see my initial value is locked, which means I start here with my state locked because it says true. Locked is true. Here, not here. If it would be false, I would start here. And the initial value for pushed and coin means there is no coin input and there is no push input. Okay, so we have covered this one with this little part that was this here. And we covered all the states which I need. We covered all the inputs which I need. And now I can simulate here too. So you can see here I start simulating here. And here I simulate here too. And then I say, okay, I said here we can start with the state. Here I am, because here I have to start. And I see this, like I said before, the arrows indicating an input. From this state, I make a coin input, okay? I write here just coin true, because this is just my input, which means this coin true means here the person is putting in this machine a coin. This is this, and in programming it means just we set the coin to true, which was at start to false, right? And now coin true means also this is just the input from the user, and when the user is putting a coin in the machine is reacting, and reacting to does the machine all time with a function. And you can see I create here a function, and important is I use the input for the function because I want to evaluate this input here, right? That's why the function is the reaction and the coin is the input on what I want to react, and this is indicating this arrow here. Right? And now let's jump to the function, and you can see the function is very simple. A void function input was, like I said, we need a coin. And that's why I wrote here coin param. I made them bool. And the only thing which the function does here, you can see it's a if check. If this coin param is true, it checks if it's true or not. So coin param, this is the coin, which is setting here. If it's true, I will go to the state unlocked, which means if this coin is true, which means you are putting indeed a coin in it and not anything else. For example, if you put another thing in this machine, then if this is true, then I say, okay, you can go from this locked to the unlocked state. And that's it. That is the description from here to here. Then the next simulate, and then I put this out just for showing. The next simulate is, okay, let's see what happens if I put again a coin in it. So I go from here to here just for check purposes. I put again a coin in, and then it must come out this state here, right? So, okay, I put a coin again in it. Here's the coin user. Again, it jumps here on coin. It checks. If this coin is true, it says the state locked is false again, which means it stays here. You can see this one is simulated as well, the same function. This one, if it stays here, it goes here to false, to unlocked. If I was in unlocked, I stay in unlocked states. In unlocked, encoding means you still set this to locked. This is the same thing, but in state it looks like it stays at the same point. And that's it. That was the coin function. Now I can make the push function the same thing. Now I simulate the push. Here, the push one. Let's see. Push user. And again, input, push. This is the input, for example. And then the function who reacts to this input is my push here. And again, this one, we have a if check. And you can see the push if check will stay. If it's true, it will set it to locked, which means if I was here, for example, you can see the push will go to locked. If I was already in locked, it says I go still to locked. So with other words, this one here cares not so much what you do, because this push is going all time in this case to these places. But important is it depends all time. So for our understanding, when we read the state diagram, for us, it's important where we are. For example, if I'm unlocked, I change the state. If I was in locked, I change not with state with push, for example. And that's all about state diagram. And you can see this is the code, or let's say the basic code, because I have not coded the input here. But that's it. That's all what we needed for our state diagram. And now let's compare this one more time. You can see this code here is very simple compared to my random approach, which is not even finished. I just stopped there because I used here something with rotate, then I compared here with pushed coin and push at the same time anyhow. I don't know, but it's not wrong. Careful, it is not wrong. Of course, you can make a logic with push and coin. For example, you can say, okay, if you what I made here is, for example, I said, okay, if you try to if you have a coin, you can see here's the coin, and if you try to push, then it should pass. And I have here another logic because I have here also a rotate, which means you can see this this metal thing. When you push it, it can rotate and all these things, but it's still not good. It's also not absolute perfect. And the whole thing, what I try to do is when we compare now this two code, this would be much bigger and bigger and bigger. This code is the same. It calls in programming equivalent. It is not the I mean, sorry, not the same. It is equivalent. Equivalent means the end result is the same because I make a code which describes this object, but this code here is better because you waste not time with other things. For example, no time with other variables. You just concentrate on that what you really need, and that means in future you don't waste time. Time is very valuable. And perhaps you waste also not money on the development time. Instead, you can concentrate on finishing your project and then trying to find bugs if there are any and so on. So with that said, let's go back fast to my last example here. What means this for my example here? Here, again, I made here a random approach. Random approach means that was the thing what I did here as well, this way. I have not made a state diagram, which means I just started with 4 nodes and then I coded something and I hoped it worked, and you saw it worked indeed. It is good. But if I would use, for example, now a little bit more think ahead and use perhaps a state diagram and a flowchart in combination, I could make this code what I programmed here not perhaps in a better way, not necessarily, because I try anyway the same later, because this one is a prototype, and if I optimize it, it will be equivalent. The same goes for here. This is here, approach is prototype. If I would optimize this one, it would be later equivalent to this one here, probably to the perfect solution, something like that. And that's the whole story why I explain you the states. It can you make your life easy in future, but right now we are still starters. We are more training here this keywords, and that was here again. Here I simulated this one. Here I created function, and the last thing what I want to do here, because we are training keywords, we are in classes, and this one is not a class. I want to convert now this one in a class, and you see in C++ you can program in functions. You can see that was a function where I use just functions here. That works. We already made this, and now we learned classes and we want to use objects, object oriented. And nice thing is you can just create a class and put all the functions and the variables in the class. But again, you can use also the shortcut. You can make it manually, or the shortcut, again, right click. You go here to the quick actions and refactoring, and here, oops, that was not it. You go to the other one, not this one. I thought it was, this is function creation. But anyway, you can go here to snippet, surround with, and you can surround it here again with a class. I think so. Here, there is a class, you double click it, and now it created a class. So with other words, it just surrounded it. But careful, when you surround this with a class, we have still to do, this is just a template, we have still to name the class properly. Let me do this. So let's call this here, let's see a nice name for this one. What is that? Let's call this class, what do we call turn? Let's call it turnstyle or turn. No, not turnstyle. Let's see, what do I call this one? So the class is doing this, simulating this one. Yeah, let's call it turnstyle, whatever. Turnstyle. Okay, let's call this one turnstyle. And you can see it created here automatically these two publics. What are these two things? The first thing we discussed, the second thing we discussed not really, but the first thing you can see has the same name as the class, which means it indicates a constructor. We learned this. And in my case, I don't need a constructor, by the way. So with other words, if you don't need a constructor, then you can kick it. But what is the second thing? It starts also with this the symbol here, and then it uses here the same name. It is a destructor. We have not talked about this. Destructor means when you end this object, for example, I create here this object anywhere, and if the object is not used, then the destructor is releasing all the variables again. But this one, this important is this destructor is called automatically by the compiler. So we don't have to use this normally. There are cases it will be used, and that's why it is indicating here. But we as a starter will not use it much. But later when you go a little deeper in programming, there are special cases where they use the destructor. But like I said, but important is for us beginner that you know this is a destructor. Okay. And now we have here another problem. All the variables, this program made it private, but here you can see I need it outside. Outside means probably that I can't use it private. So let's change this one to public. And this is in general a bad idea. Why is this bad? Which rules is this? First you start private and you go up to protected, and public depends on your needs. And I already see that I need, but I want to show you this a little bit more accurate. Before I can show you this accurate, we have here some arrows. And the arrows is why I have here arrows. Can you see this? It's very simple. I have here arrows because this was just the coin variable, but I use this coin variable here, but I use a class now, which means I have to tell again here where this coin is. And we make this by creating an object, because I need to create a object of this class and then say this coin here, which I want to use, is in this object of this class which I created. So let's create our object. How we create a object again? Very simple. We use the class name and we put this in, and then I call it my turn simulator, for example. And you can see I have not created here a constructor. So you can see I have no constructor here. I have there was a constructor. That's why I can make it like this if you want. But of course you can make also your own constructor. We have talked about constructor, but in this case I'm not using it. I don't assign any values to it. Why I should make it? Just don't make it if you don't use it. So the next thing is this coin here. I have to now. I use not this coin here, which was public. Now I want to use here from my object here, the coin. And we learned this. How we make this again? We name the class name and then a dot for accessing. And now I have specified this coin. And here it's still an error. And that's the strange thing, because this one is right. The syntax here is right. The question is now, why is here an error? This coin. And we go up and we can see it is private. And I said private means only the class itself here in this body can access it, right? Which means to make this error away, we have to change. At least we start with the bool and put it to public, and we make it step by step because that's very important. We don't want other variables public because that can cause problems, or at least debug wasting time in debug when they are public, because they could be in many other places. That's why we keep all the things private as long as they are not called outside of this class. So, but the problem is here, Here, the function coin user shows also an arrow, and the reason for that is it is also in our class, which means we have use here also my class. Again, the dot for accessing it. And let's see what's the problem here. It says here still a problem. So let's see. Void coin user. And here is the coin. And here the same problem. We have to put this one up to the public section because I need this here. All right. So, and here I have still a problem. It says here coin. And again, careful. We have to call it now all time, specifying which coin we want. And I want the coin from this object, which means I have to use all time this notation here. Again, so you can see when you convert a function to a class, you have just replace all the variables with the object name here to access, but it's not difficult. You can see it was not really difficult. And then you can go on this locked here. I access it again outside, which means again, I use here the name dot, and then you can see it says still an arrow, which means I need a public access because this one is again private. Okay. Let's push this one, and the other one will be there too, so I don't want to waste time. Let's make this here, and this one will be also go to public, and I have nothing in private later here because I have all time access this kind of stuff outside. And we can make here one more thing to make it a little bit more easy. You can see we have here a function, and then we have here variables, and to make this a little bit easier to find later, we can say, okay, here on top variables, and here later we make the functions. Oops, not this. Here we make functions, and this one is almost converted. And again here all you can see is I have to use the object name because I'm using now the object, and because they are not pointers, I have to use the dot access specifier for all of them. So, and I converted this one to a class. So that was already the conversion. You can see you can use a function approach, or you can use a class approach, which means object-oriented approach. That depends on you, what you like, what you think it's good for your program. And with that said, we are almost finished. Let me with that. And then the last thing what I want to show you is in my approach. I was starting talking to that my approach, the thing I could go here. That is so converting. Here's one more thing. We have here turnstile. That was the constructor and destructor. They were defined outside. I don't have any constructor, but we learned also we can define constructors outside, so we don't need that because I have no constructor, at least not I create, not the compiler will create a constructor. We learned this. And the last thing what I wanted to show is this approach here, and how could I make this better? Because before I showed you this, I showed you these two codes. The approach with the state diagram here was really good. You can see the code is here very simple. Here one little class, here the variables, inputs, actions, and here is the simulation. And when I compare it with my class here, which I tried, yeah, this it looks a little bit wishy-washy, but like a prototype. Prototype means you just throw in and hope it works. And later, if you optimize this code, it would end up probably similar to something like that. Perhaps not exactly like that, but similar. And to avoid this, like I said, you can try to start not with coding. You can try to start with creating a state diagram. It's not easy at the start because you need to learn state diagrams a little bit more in depth, but it can be worth. And the best part is actually what you really need is to identify the state and the input, because the input will determine where you can go. So we have a start, we have a state, and when I show you this one in my code here, let me show you how simple that would be here. It looks very crazy. You can see that looks very crazy, right? But actually it's not so difficult. First of all, I define a start point here, something. Oh, where's the diagram? We need us defining a start point. Okay, then I define it. So start point, like I said, is here like a like arrow. This is a good thing. You can make it so. That's all time good. This is just the start point. But important in my case, the start point here, in my case, has not a state. Because the start point means I can choose now how the input goes. So in my case, I make here a circle. Like I said, circles are states, and I just call the start without nothing. Here I start. And important is in a state diagram, the inputs, right? The inputs will tell us which states we can go. And this is the thing what we want to identify in a program, the states where I can go, where I not can go. And then I can say, okay, what is if I have, and now I said in a state diagram, the arrows are very important because they are the input. So let's say I have an input, I make a shortcut. Let's say I means input. And the numbers, when I make here, for example, I0 means how much nodes I have, for example. That means 0 nodes. Also I input and input, let's write it again, input with 0 nodes. The numbers are 0 nodes, for example. And if I have here I1 would be, oops, sorry, not this. Just for, again, for shortcut, because I want not write here the whole thing here. That's why I want to use the shortcut. 0 nodes, if I have here I1, then I have here input with 1 node and so on. And I have to test all the inputs now, right? So this was just info. This is not the state diagram. This is just info. So a separate input that we know what the shortcut means. That's also very important that you write the info there, because if anyone is reading your shortcut, for example, you can see if I read here this shortcut, I don't know what this S1, S2 is. Here is no info. It's missing. But it's they just want to show you this state diagram. You can see they indicate here the start point with just an arrow. So we don't need this thing. There are different kinds. But what I'm doing more is this one. And they are not even indicating here the start point. They are writing start, but it's better just to indicate the start. And here, this is the start point. And this one is what I make. So I have here a start point. Let's go here. This is the start point. And now you see, I just watch all the inputs which I can have. I say, okay, let's say I have an input of how many nodes? Just let's start with 4 because I started with 4. Let's start with 4. Why not? I make it here because I know 4 nodes are here. Input, I with 4 nodes, the number 4. Input with I4 means input with 4 nodes. And I call here, again, state is a circle. And I call this S4. Let's call this just S4. Again, nobody will know what S4 means. Let's write here a comment. S means use code. S4. Okay, I have to write this one out because this is the full state. Let's write it here. Again, info. S4 means here use code. Use code with 4 inputs. 4 inputs. Okay, I have this. That was this one. And let's say now, because state diagram are very important, like I showed you, we are interested in all the inputs, right? Because the inputs can change it. Input means you can change it, must not change it. And I have now to check in my code if any input can change my code which I wrote for this 4 nodes here. You can see the 4 nodes was my code where I used this while loop and yes, and setting the pointers. That was the code which I use here. But my question is now, is there an input which says you can't use your code? And let's start it. We test it. We have just to test it. You can just start with 0. Here I say input 0. And input 0, you can see, wait a minute, this state input 0 we can't use, because input 0, you think about it already ahead. If I have input 0 means I have no nodes, which means this one reacts on nodes, right? We need here setting up pointers, we compare the pointers, we move the pointers, we loop the pointers. When I have no input, I can't do anything of this, which means I can't use the code, use code with 4 nodes. I can't use this. And then you can here just stay without thinking too much. Okay, let's describe this I null with another state. S0, let's call this S0. And of course you have to describe this S0 again. And I make this not here, but you know this. S means use code with 0 inputs, right? So 0 inputs. 0. This is all time the same. 0 inputs. Inputs. And now, again, you check just the input in a state diagram. What happens if you have one node? Can I use this code here, or can I use this code here? Because you don't want waste time, and time means again coding all the stuff here again. So if you input can use one of these codes here, then you can just say, for example, let's say it's possible that S2 can use this code here. Then I would make it so, because I don't need to waste the creator code. All time when you see a state here means most time I have to handle or create a code, another code in this case, because it handles the input differently. But if this code not needed, then I don't make it. So here I would not make it, but the problem is my S input, oh, sorry, that is I1 by the way, not input 2. My input 1 or my input 2, both, you can already see they are not working with my code, which means, first of all, if I have one input, my reaction is, no, input 1 will not react. You have to create or watch this, how you handle this differently. Then you make this one S1, and then you can already see what happens if this one you are doing here. You can say, okay, 2 nodes, I can't use my 4. You can see here, 4 I can't use because here I use a for loop in this case. And when I have 2 nodes, I can't use, for example, this one. And I handle this differently. I make S2. Now the question is with 3, what happens with, that was input 2. Let's make here input 3. And input 3 says here, interestingly, let's write it first here, S3. S3 says here, wait a minute, S3, if I have 3 inputs, my S4 is exactly do the same thing here, like S3. Because later you will find out, you can assign here, for example, pointers. You can make here the comparison, and you can loop here to the next place. So which means you will find out that S3 with 3 inputs and 4 inputs are the same. And when you see something like it is the same, you don't need to do this. You can say, okay, I don't need waste now to time with creating S3 code. You can just say, because this is the same, I can, I don't need waste time here for S3. I can just connect this from here with an input to S4, for example, and say this is the same like this code here, right? This I3 here is the same because they are doing exactly the same thing. And interesting is now, let's try this one with S5. Input 5 with 5 nodes or with 1000 nodes. Let's make this here. I want not to make it different. Not with this color. Control Z. Let's try this now with, let's make it here just for this purpose here. So let's write here input 5, and let's see what happens here. And let's call this just for fun S5, because we need a code which can handle 5 inputs. And when we watch these 5 inputs, we will see again, wait a minute, the code which can handle 5 inputs, it's the same code which can handle 4 inputs, because I built there nothing new. So I use the pointers again, I compare, I move the pointers, and then I loop, and that's it. And a 5 node do the same thing. So again, I have here again the same thing. So S4 is the same as 5, which means don't waste time to create here another code. Use this I5 goes here again to I5 goes again to this pointer 4. And now you will realize when you check a little bit more inputs, or here you already realize, the more nodes you put into, all will lead here to S4, because there comes nothing new. So if there would be a new code, then it will happen, but all will lead here to S4, which means from this point on, I don't need anything new. It is this code S4 which I started here, and S3 is here too, because I started with 4 nodes. Normally it would be 3 nodes, but that was my start point. It's okay. And this is the code which I use here all time. And this here are the codes which I have to create. And that's it. That would be a very simple, at least here I demonstrated which initial states I need. And with that said, I could now create here a program with this one here. So instead of creating here, my super crazy program with jumping all over the place, I could just say, okay, let's create here 1, 3, 4 coding blocks which reacts on certain inputs, and that's it. That was similar to this one here. You can see here I started with random anything. I tried the different variables and all this kind of stuff. Instead, if I would use now the state diagram like they did here I used here the random one. That was that not so good approach. It will work, but you can see there are still random approach which can be not very effective. And here if I create a state diagram and then I created now this code, it looks very simple. And very simple means here you don't waste time creating other code which you really not need, which means you don't waste time here. And here the same goes now with this one. If I would create first a state diagram like this one and say, for example, okay, from my inputs, I just watch again the input. I need this here, handle input with one node. I need a handle code for 0 codes, for 1 nodes, for 2 nodes, and for 3 and more nodes, 3, 5, 6 are all things. And this free code section, right? This one I had to program, no more. All other things what I did is not very necessarily. And this was here so that what you can use in future to make your life easier. But again, as a starter, don't worry if you understand nothing like this. This state diagram and flowchart, these are only here to make your life easier in future. Let's say after you finish the basics and you know all the coding stuff, later you don't want doing something like this one, trying to prototype, just randomly starting this one. This one we do here as a starter, and this will work too. So it will work, but it will cost a little bit more time. It will cost a little bit more tests. It will cost, yes, your time. And you say, instead of using, let's say this random approach takes 3 hours and this approach would take, let's say, only 1 hour, then you will say, okay, it is worth perhaps learning this one in future to don't waste time. And the best part is it is not only wasting time, it is making your code a little bit more efficient. What I mean with that, you can see efficiency, you don't use code which is not really needed. Here I have probably code which is redundant, which means it can perhaps help, which I would optimize later away if I go to the optimization steps. But here you can just concentrate on the very important code. Like here, when I make here the states, I could just start now here Input for 0 nodes, code this section. Input for 1 node, code this sections. And then input for 2 nodes, code this sections. Input for 4 nodes will cover all the other things, code this sections, and that's it. That would make the whole code, what I make with the sort algorithm, faster, easier, very easy to explain everybody, because here, if I explain you this one here, of course not so, but if I would have now a clean state diagram and explain you the inputs, this one would everybody understand, right? This diagram here, and easy to follow. Instead of explaining here the code, what I did all time in this tutorial, I tried to explain you here. Okay, then we go here, and then we go that, and then I need this. Yes, so I'm almost finished. There is one last thing what I want to say, which you have to consider. Don't confuse state diagram with flowcharts, because I showed you this also. This one looks more like a flowchart. This one is not a flowchart, but don't confuse you. We talked about flowchart with state diagram. The big difference is this arrows in a state diagram, like I said, these are named arrows. Named arrows means these are code execution. Now let me show you this one here. Here, this is a code execution, which means in a flowchart, this arrow here, this arrow, let's say here, this arrow E0 input 0 would be not an arrow. We know what a flowchart is. Let me make this one. So here we know a flowchart has here a start point, right? Then we have this one, and then we have perhaps a decision point, and then we can go here, and then I can decision true, false. I can make here code execution, but code execution, the path is going, and this kind of stuff are all arrows, right? Important is these are just normal arrows which indicating the path here. This one is not indicating a path. It is indicating a code execution, which is an input. And when we compare, this one are not the same. Very important. This one is not the same, because here, when I transfer this one here, this AI0 to a flowchart, that would mean something like that. I have input. This one here, this input would be careful. When I mean here they are not the same is when I mean it's the arrows are not the same. Very important, because now I translate this one, and a flowchart would be, this is a code execution, and we know a code execution in a flowchart looks like this, and this could be this here perhaps. How I can see that this one is a code execution. How I can see input, because let's go back to the code. Let's go back here, and here my flowchart here, this is a input is here. I simulate the input. It is just code execution. In a flowchart, I would make this one as an input here. Input, and input means here I set here the coin to true. That's the code. But this input, this whole thing here, is represented in a state diagram as an arrow. And this one can change the state. We learned it, but must not change. So careful about this one, that you don't mix this. And that's why I said careful about diagrams like this one here that looks similar to a flowchart. You have here decision making, you have here code execution. But they have probably defined it right, because it would be not here if this is not right definition. But in general, as a starter, I would stick here with this one here. Arrows are code execution. Inputs, very important. And with the inputs, you will find all the states which you need. All right, with that said, if you understand this one too, perhaps watch this again and compare this one here again, that you make not this mistake. States. Arrows are very important because they are the inputs which can change the state, must not change the state. You can see here my I5, I3 are not changing the state. They are going to the same state like I4, I3, I5 from the start point. But I0, I1, I2 are changing the state because I can't use this code here. I have to use the separate codes. If you understand this, is very good. And the last word is, this is all just for future to help you, because you want not waste time. You want work more efficient. But as a starter, don't worry if you don't use this, because as a starter, it's absolute okay if you just finish this random approach, because this is more work. This is actually the harder part. As a starter, we are doing this random approach is more difficult. You can see this just by this coding. Here, the random approach means you try all out what you know and hope that it works. This approach tries not all out. It is just following some rules. The code is very simple and it will work. So no problem. Just try the harder way at start. That's good, because then you learn a little bit more coding. But in future, you will probably skip this, because you know all this coding, and then you say, no, I don't waste time. I make the short approach. All right. With that said, I stop this video with all these diagrams and state machines and flowcharts. We will talk about a little bit probably, but we will go in the next video back to our exercise, and I will continue here with the other function. But the other function I will make short. I will not go too deep into them to explain all things in, like I did here, for example, with sort. That was a really, introduction to other parts of programming, which we will do more in the future when you finish the basics, because we are still in basics. All right, in the next video, we go for one of the other ones. I don't know which one. It's probably search. And with that said, if you have any questions or anything what you want to comment, you can do it in the comment section. See you in the next video, and like all time, try it on your own. Try all the things, not just understand it. Try it, make it, and prove yourself that you can do it. And of course, have fun. And bye, good luck, and see you in the next.